All right, so for this third one, just notice that you've got a definite integral for one, and the form that we're looking for, this is our u squared minus a squared. U squared minus a squared, that is a secant substitution. So again, we'll just go ahead and identify what's the u. U is, again, just x. A square root of 9, 3. So the thing that we set u is equal to is x, so that's what we're going to set equal to a, in this case, secant theta. And then again, don't forget dx, the derivative of that, 3 secant theta tangent theta, d theta. Okay, so that's the initial stuff. Just think about the definite integral. It is possible to just go ahead and change these bounds according to the eventual substitution that you're going to make. You can do that, or you can just find the antiderivative, and then once you're done with that, then plug in the bounds. It really doesn't matter. I'm just going to go ahead and do it by first finding the antiderivative, and then we'll plug in the 4 and the 6. Carrying the substitutions along with the bounds is a bit tricky. You just have to make sure that at each step, if you're changing from x to theta or whatever, that these values change along with that. Okay, so like I said, I'm just going to do the antiderivative. So if we do it that way, then see what happens to our radical term, x squared minus 9 under the radical. What's going to happen to it with this particular substitution? And we said that x is 3 secant theta. Notice that if you square that, you're going to get the 9. So 9 secant squared theta minus 9. Factor out that 9 under the radical. What are you left with? Secant squared theta minus 1. Again, we've got an identity there. Secant squared theta minus 1 is tangent squared theta. So that's a tangent squared. That's a 9. Take the square root of all that. You get 3 tangent theta. So that's what's going to happen to the term under the radical. And again, we're just looking at the indefinite integral here. So the x we said was 3 secant theta. That's squared, so we got to square the whole thing. We'll get 3 secant theta squared. The dx, let's put that in the numerator as well. 3 secant theta tangent theta d theta. The denominator, the radical term, we just said what happens to that, becomes 3 tangent theta. Okay, then these tangents can cancel, and these 3's can cancel. And what integral are we left with after that? What is left? Squaring that, you get 9. Secant squared, and then there's another secant, so we get 9. We'll put that up front. Secant cubed theta. And if you remember from when we did the trig integrals in the section before this trig substitution, the integral of secant cubed was fairly difficult. And I wouldn't ask you to find that on a test. So if you ended up with a secant cubed integral on the test, I would just give you the antiderivative for that. So anyway, I'm not going to do it here. We did that in class already when we talked about those trig integrals. So I want to just go ahead and give the antiderivative for that. So the antiderivative of secant cubed is 1/2 secant theta tangent theta minus 1/2 natural log of secant theta plus tangent theta. Plus, not minus. Okay, so if we distribute the 9 in there, we'll get 9/2 in both of those terms. So the next thing we need to do is change this all back into thetas, into x's. So just come back to your initial substitution of that, And we notice that secant of theta is equal to x over 3. And then you can draw theta in a triangle. We know that its secant is x over 3. Secant is hypotenuse over adjacent. And then the third side, Pythagorean theorem, gives us x squared minus 9. Again, check, that's what we had up here in the denominator. So let's change this all back into x's now. And we'll distribute the 9 as well. So we're going to get 9 over 2 secant theta, looking at the picture, or really we know what the secant of theta is, just x over 3. So x over 3, tangent theta, tangent opposite over adjacent, so we're going to get square root x squared minus 9 over 3. Okay, and then plus, again, we'll distribute the 9 over to here, so you get 9 over 2 natural log of, again, secant theta is there, x over 3 plus the tangent of theta, square root of x squared minus 9 over 3. Okay, now I'm not going to put a plus c on this one because we do have a definite integral here. So for the definite integral part of this, we have to plug those numbers in. So let's redo this beginning part. We've found the antiderivative now of this function here. We know what it is. We'll go ahead and simplify it a little bit. The 9 and these two 3's will cancel, so we're just going to have a 1/2 in front of this. So we'll have 1/2 x square root x squared minus 9 plus 9/2 natural log of all this x over 3 all that, and then we have to take all of this and then plug in the two bounds of 4 and 6. Okay, so plugging in 4 and 6, I'm just going to write this and speed it up in the video. So let's see, if we plug in 6, we'll get all this. And small mistake there, that needs to be minus since we're subtracting it. Okay, after all that, see what that is in our calculator. So this can be simplified. You can of course simplify the fractions and all that kind of thing. For the purpose of what we're doing here, just to make sure that we have a answer that we can all compare, let's approximate this as a decimal. We get about 12.64. So approximate answer, this, if you can simplify this considerably, but yeah, 12.64, good decimal approximation.